Hey guys, it's Emma. Welcome back to my channel. In this video, I want to continue talking about window functions in SQL. In a previous video, I gave you an overview of window functions. I talked about what is a window function, the syntax of window functions, how to define a window frame, as well as how to select a function. I highly recommend you watch that video before today's video because this video is more advanced than the previous one and you need the fundamentals to understand examples in this video. Once you finish the overview, come back and we will dive deeper into window functions and I will walk you through some solid examples. In this video, we'll go over 3 examples using 3 types of functions: aggregate functions, ranking functions, and analytic functions. Once you have finished watching both videos, well, maybe you need to watch multiple times to fully understand everything. You will be able to use window functions to tackle lots of problems in your day-to-day job as a data scientist, as well as in interviews. Okay, let's start with the most common used functions, aggregate functions. They are simply computing the statistics within each window or group. They're the same functions that you can use with a group by statement such as sum, average, mean, max, etc. Let's look at a simple example. Find the team size in LeetCode. We have a table called employee which contains employee ID and team ID. Employee ID is the ID of each employee and it's a primary key of this table. Team ID is the ID of the team where the employee belongs to. The requirement is to output a table that contains each employee ID and the size of the team. From the initial table, we know the employee ID and the team ID, so we just need to get the size of each team, then we're able to solve the problem. To get the size of each team, we can use the count function to count the team size. Here inside the over clause, we partition by the team ID because we want each team to be considered as a group. This creates groups that contain rows of the entire team. So the count function will return the size of the team for each row. We also need to select employee ID, so the query will return the employee ID and the team size side by side. This is how we solve the problem with an aggregate function. Moving forward to the next example, it involves using a ranking function. Now, a quick recap of ranking functions. They are functions aimed at obtaining a ranking of each row within each group, and the rank starts from 1. They are very helpful to solve problems such as selecting the top n records in each group. The commonly used ranking functions are row number, rank, and dense rank. Let's look at the example together. It's called department top 3 salaries. We have a table employee with employee ID, name, salary, and the department ID. The other table that is given to us is called department, which has the ID of the department and the name of the department. We also know that department ID in the employee table is a foreign key of the ID from the department table. It means that those 2 tables can be joined based on those 2 columns. The requirement is to find all the employees with the top 3 salaries in each department. Here we have a sample input and output. There are 7 employees in the employee table and 2 departments in the department table. From the output, we see there are 4 outputs for the IT department and 2 outputs for the sales department. So even though what we are looking for is the top 3 salaries in each department, the number of rows in the output table for each department may not be 3, because some departments do not have 3 employees. In this example, there are only 2 employees in the sales department. Also, some departments may have multiple employees having the same amount of salary. For example, there are 4 employees in the IT department because 2 of them share the same salary, which is 85,000. To solve this problem, we need to get a ranking of employees in a department first, then select the ones with a rank that is less or equal to 3. So let's start with obtaining a ranking of all employees. We can create a subquery to make it organized. We want to select employee name, salary, and the department ID, which are required for the output. Then we use the dense rank function to get a ranking of salaries within each department. In the over clause, we can use partition by department ID and order by salary in descending order. This way, we get a ranking of employees within each department, and employees with the highest salaries are ranked number 1. Note that here we use dense rank function instead of other ranking functions such as row number or rank. This is because the problem requires returning all the individuals with the top 3 salaries in each department. For example, in the IT department, there are 4 people with the top 3 salaries and 2 of them share the same salary, which is 85,000. Using that rank, we can get the ranking in sequential numbers, and employees with the same salary will have the same rank. This helps us select employees in the next step. The next step is simply selecting those employees with ranks that are less or equal to 3. That's how we obtain all the employees with top 3 salaries in each department. Now, if we update the problem to the top 3 salaried employees, we want to output at most 3 employees per department. And if multiple people share the same high salaries, we only need to select 3 of them. Which ranking function would you use? I will leave this question for you to think about. Feel free to comment below to share your thoughts. Okay, the last example we are going to look at involves analytic functions. Analytic functions calculate an aggregate value based on a group of rows. Analytic functions are frequently used to compute moving averages and rounding totals. Also, we can use them to compare rows within a group. Let's say an example. This is another SQL problem on LeetCode, which is called active users. We're given 2 tables. One table is called accounts, which contains the ID and name of a user. The other table is called logins, which contains ID and the login date. Each time a user logs in, there will be a record in this table. The problem is to find out active users, which is defined as users who log in with 5 or more consecutive days. For the purpose of this example, we assume a user only logs in at most once per day. That is, there's at most 1 record of each user on each day in the table. Here is a sample input and output. We have the login table with user ID 1 and 7. So only a user with ID 7 is an active user based on the definition, because this user logs in 5 consecutive days. Then we can output the user ID and their name. The key to solve this problem is to translate the logic that the user logged in 5 consecutive days into a query. If you think about what 5 consecutive days mean in this case, we know that for a person to log in 5 consecutive days, the difference between the first day they log in and the 5th day they log in must be 4. In the examples shown on the slide, the example on the left indicates a user logs in 5 consecutive days, and the difference is 4. While the one on the right indicates a user did not log in 5 days in a row, and the difference isn't equal to 4. Now, once we understand this logic, we can use a window function to solve the problem. We first select the ID and login date from the login table. Then we use the lag function to get the login date that's 4 rows before the current row. That's the date users log in 4 times before the current login date, which we can call it lag 4. Then we can take the difference between the current login date and the lag 4 login date. If the difference is exactly 4, this means the user must have logged in for 5 consecutive days. The date function is used for calculating the difference between dates. In Microsoft Transact SQL, we also need to specify the unit of the difference, which is in days. And we want the date difference to be exactly 4. Based on that idea, we can finish up the query. We can create a subquery to obtain lag 4 and join the results with the account table to get the names of users. Note that we need to select distinct user IDs and user names because one user may log in multiple consecutive 5 days. If we don't use distinct here, one user may appear multiple times in the output table, which is not what we want. So this is how we write a query to check continuous date ranges using the lag function. Of course, you can use the lead function to solve the problem as well. Feel free to try it yourself and see if you can solve it using the lead function. Alright guys, we have talked about 3 examples ranging from easy to hard using window functions, and now you know how to use window functions to solve real problems. One thing I want to mention is that you can use other functions to solve those problems too. You don't have to use window functions. We can use some subqueries and joins to solve them too, but the query will become super long and it becomes a spaghetti query easily. In practice, writing more concise and readable queries will help reduce chances of bugs. That's why it's helpful to learn window functions to know how to write queries in a concise and readable way. I hope this video gives you a better understanding on how to use window functions to solve problems. Because you really need to practice to become a true master of window functions. I have collected and shared some LeetCode problems related to window functions below in the description. I am not affiliated with LeetCode, but I would encourage you to get one if you can. If you choose other platforms to practice, such as HackerRank, Mode Analytics, or any other online coding platform, that's totally fine too. At the end of the day, the most important thing is you do enough practice so that you are comfortable with using window functions to solve real problems. That's it for this video. Don't forget to subscribe to my channel if you haven't done already. I will see you in the next video.